Oye, aquí este es el barco del PDF en español. Mi español lo siento muy mal, por eso he escrito todo en inglés. Después voy a hablar en inglés, voy a probar, soy alemán. Pero it should be possible to download it with a mobile, ¿sí? Vale. Y aquí hay algunas cosas para vosotros, bolígrafos y bottle opener, I'm not sure what's in Spanish. And ¿cómo?
En Spanish, destapador.
Después. Okay. Yes, and tarjetas, in case you've got questions. But we might slowly start, okay? And I switch now to English. So this is about something called WebAssembly. I think it's a very, very powerful thing. And I think a lot of big companies are working on this. So you sit in a talk where you might, if you do something with computer or just for common knowledge, it might be very important for you to know about this. And in the last few days, I spent a lot of time to make it easy. I tried to understand it myself and explain it easy. And if I'm getting too fast, you can give me signs and I try to slow up. Okay, we've got plenty of time. So, I'm a freelancer, but a friend of me, Thorsten Behrens, who has a company, Orador, asked me a few days ago if I would like to go to Mexico, and I said, yes. What a question. And I was very happy that I shouldn't have not to do any marketing slides, but I could talk about and read myself again into WebAssembly. So just wait for people. There's the barcode. If you catch your mobile and try to download it, then you might have it in español. Chicos, hay una barcode de la profesión en español. Okay, anyway. Okay, we start here maybe. So, let's see. So who am I? Who's talking? So I started at Starter Vision, that is the company that bought up by Sun Microsystems, who invented Java, in Hamburg. And Starter Vision had some office called Star Office, which became later Open Office and is now LibreOffice. So in 1999, I started there in Hamburg. And I also worked on the file format. I'm the co-lead, co-chair of the ODF, the Open Document Format, technical committee at OASIS. We are standardizing the blueprint, like a cooking recipe of how the file should look like. This is the next talk in the other room of myself. And also, we all had 2 web offices, like Google Docs, in Hamburg. And we used this Java-based ODF toolkit to download it. Sorry, I was thinking I had made a change, I didn't see it here. Anyway, we'll see how the slides is. So, it's a Java backend for opening and manipulating the ODF file. So we transformed it to HTML so it can be shown in the browser. But this is just backend without view, but you can automatically process an ODF file. And it's very helpful, for instance, for translating or extracting. And the other thing I'm co-owner or maintaining is something called ODF to XHTML. So it's transforming it with something, a language called XLT filter. So whenever you have LibreOffice and you say export and to XHTML, this is being triggered. Okay. And now who's allotropia? And I had a problem to remember the word, and I wasn't aware that it exists and what it means. Allotropia is when there's a chemical element which has 2 different representation, like a diamond for carbon and graphite. Yes? So this is allotrope. And you see it's like from other and form, from Greece. And you can't even have a more complex form. I never heard about this buckyball. It's carbon 60. And this is the quote from the website saying, when you keep something in the free open source, then it might become sometimes a diamond, or sooner or later, or it's just a buckyball. I find it quite nice to remember the name. And something about Utopia, it's from Thorsten, he's CEO, and he's also on the board of chairpersons there. And they are, or we are, I'm more external, but consulting enterprise and governments and on LibreOffice. And they are the biggest company supporter of ODF. Michael Stahl, a friend or colleague, also from StarOffice. He's also a co-editor in the Oasis ODF-TC and also co-maintainer. It's always good to have 4 eyes on a thing and to ask. So that is the background. So what are we talking about? From a high-level view, there's something called WebAssembly, Lover, another thing. And it's a port, a native port of LibreOffice running on the client side in the browser. And yes, so it was sponsored by European Commission how I said, it's a common institution from Netherlands, NLNet. There was former public telephone company, and that's becoming a foundation. And they gave money, and they got from a European Commission, the campaign called Horizon 2020, money to port the C++ code into a browser by using this technology called WebAssembly. And so why do we need WebAssembly? And I would like to jump very back in the past. I'm not sure if you've ever seen such a thing. It's called a punch card. It was used to program. You had 80 characters on such a card, and then you have a box of these cards that make the whole program. And beware, don't let it fall, because then your program is shuffled and you have to reorder it manually, yes? That were the old days. And they were right once, yes? If you make a wrong punch, you have to, I'm not sure if you can tape it or something, likely not. And I was just thinking, how many punch cards does LibreOffice might have with 10 million lines of code? Okay, not every line of code had 80 characters, but the millions of these code cards. So this is in the very old days. And just I go very back to give you an understanding now about software. So these were the very old days. And next, and just to understand why WebAssembly is an answer, I'd like to tell you what is the problem. So from a high-level view of programming, there's one hand the source code of a programmer, which is a very high-level semantic. Yes, it's a text file you can enter, and there the programmer knows how the data should flow in the program. It's like water or liquid flowing through the document, for throwing through a program, and the programmer knows on what events, external events, it might change the course or how it's been altered. And on the other side, on the machine, it has to deal with a CPU or GPU, and every CPU or GPU has a certain command set. And you somehow have to translate this high-level source code from that has been made by the programmer to this very specific CPU. Yes, and CPU might alter. Like, you know, there's the x86 or 64, I told you later. So this is actually from the both extreme ends, high semantic, human semantic, and very low-level machine, hard to read. So in between, there's something we call building or compiling. And compiling is nothing else than transforming. You see the red square, you have the text editor, so no longer punch cards. Now finally we can edit in a real text editor. Wow, yes. Still, it's like Stone Age. I mean, really, text, this would be a different talk, but adding text files is not the best way we could program. But this is the way we still do it. And then we compile it, so transform it. And I wrote ahead of time. It means ahead of the time you use it, right? You build it once, you optimize it once, and you can run it faster all the other times. Okay? So this is the usual way, for instance, C++ is being used. And then you can link it after you compile it to an object module, which is very close to the machine language. You would link it to other libraries that are on the code. There's a problem because aside of the architecture, like x64, if you want to go for, and you always say, sorry, like you want to go to ARM or to Intel's x86, you need different compilers. There are different CPU machine assembly codes. But there are also some calling conventions from operating systems. So like function parameters have been ordered. So there's a lot of, let's say, complexity here, and the compiler have to deal with this. And another view on this is, and I wanted to tell you about there's a third one, or third group, but there's a compiler that we just seen, where you have the pre-processing, you get the machine code, and then it's been run in the machine. And the other way is the interpreter, like JavaScript. So this is like C++. I think it's much faster, because you already decided for a machine, and like LibreOffice is built for various versions, and you have to download the right version for your right machine, an operating system, your platform. And the other thing is that JavaScript, it runs in all browsers, because the browser has the interpreter, and it abstracts the complexity of the operating system and the processing, so it's the ship processing, similar as Java does. Or Java is the other thing, sorry. Here's the plain, sorry, that's the third one. Here's the plain Java source code. So these are the pros, are the contrasts of the other things, yes? So compiling is very fast. And the other thing, interpreter, so it runs on, if it's on the platform, then it runs on multiple platforms, you don't have to deal with it. And this is, and like JavaScript, you can always look at the JavaScript source code. But think of it, it's a real problem. We have something like a Tower of Babel. There are so many thousands of programming languages, and each might have a different language. For instance, in Java, I'm a Java program, between Java, I think, was it 9 and 11, but there was a break and incompatibility, and it's a real pain. And also there are hundreds of computer architectures, and you might even do your own chips. So there's a lot of complexities here, and the CPU might have also, the same processing unit might have different register sizes, which also have to be dealt with the CPU, and there are different versions which had more commands. Something very special I'd like to point out here, I heard at last FOSDEM, that's a conference, Open Source Conference Europe, is that with a single instruction, multiple data, you can do very fast things. There's an example of loading a JavaScript in really high speed. I think it would be wonderful to map this to XML as well. It's a little more complicated, but this is the link. You should read into it, okay? So the other thing is the complexity now. If we have 1,000 programming languages and 100 computer architectures, do we need 100,000 compilers? I mean, this is really weird. So, of course not, because you can deal it differently. You can say, we have an intermediate language here. We build, and this is LLVM, low-level virtual machine, and they have so-called front-end for the languages, and they have an intermediate bytecode, and then they have backends, which are the platforms that we just talked about. So they somehow uncouple this complexity, and they just need 1,000 front ends and 100 backends, which is much better than the 100,000 compilers you have to deal with. And you can reuse technology in there. And this is, for instance, made by Chris Latner, a co-inventor. He also invented the I/O language Swift, the programming language on iOS from Apple. He worked for Apple there, and later Google and so on. But you can look it up. All right. And then Amscripten, that is what Thorsten was using to port, at least the writer and as a prototype in the browser, is using now, is built on Clang, the C++ LLVM technology. So I had to go back to explain you why WebAssembly is a cool stuff and what shoulders of giants it is standing. And this is something, here it's not a lie, but I think Amscripten just imports C++, but in the end, WebAssembly can be generated from every LLVM front end, so also Rust. And Rust is, you might heard of it, a very modern language which supports by design multi-threading. And the problem it solves is that the CPUs won't get faster itself, but there are more cores on a chip. So we have to deal with multi-threading. We have to embrace this somehow to fasten up our programs. And I think Rust is a great way to do this. Writer is since the 90th single-threaded, by the way. Okay, where do I stand? And here we go. The WebAssembly is in two ways. One is the binary code, very fast, and the other is in text to edit. And the very nice thing is that every browser embraces not only a JavaScript engine, but now as well a WebAssembly engine. So you can run your LLVM front-end code, like C++ or Rust, into the browser. And this is very spectacular. And this is one thing, one of the little things or projects where I heard there's a merge. There were earlier two different projects, NaCl, this is Salt, the chemical native client that was made by Google, a sandbox. And the other was the SMJS, a subset for Mozilla from JavaScript, which is very speedy. And they both joined together and gave their work to the W3C to standardize WebAssembly. So it's now a standard like HTML or CSS, and I think it's very, very powerful. And Apple and Microsoft joined as well. So where a lot of money is involved, I think it's very, there's a lot of innovation. And so the Chrome might be the new OS, like Chrome OS, or sorry, the browser, not Chrome. The browser is the new platform. It's, and when we were able to run LibreOffice in a browser, then it could be run everywhere where the browser's running. I'm not checked it, but it might run on a TV, yes, or any platform, PlayStation or whatever. So one last, more complex. I had to deal with it myself. So, and sorry for the ASCII art here. So there are three different ways of compiling. That's the same thing, like I told you earlier. We have the ahead of time, like C++, where you compile it on your machine to the machine code and have it optimized already in the beginning. Yes, that's the first extreme. So to compile time, you see there's the edit time. Yes, three different ways. The fastest is the AOT compiler, but then you have to deal with every platform, as I said. It's very complex, but this is the fastest way to do it. And the last way is the interpreter, where you keep the source, and the source is being interpreted, which is being, let's say, at runtime, being transformed, compiled. I'm not very sure here. I have to do some research and ask friends who are working in that field. I just had a week to dive into it, and there's some questions for myself as well. But so at the end the one end is do it ahead, like C++, very first, to the machine code, and the other keep the source code, and at the very end, the JavaScript, compile it. This is very slow, but you can read the thing. And then there's something, the just-in-time compiler, where you have intermediate code, like a Java bytecode, or the WebAssembly binary code. We do similar as in C++, some optimization, because what you don't optimize in the beginning once, you only have to once compile it, and then it runs fast all the time, yes? So in the end, you win a lot of time. And the second one has the advantage that you still has a certain, the complexity of the platforms is still at the interpreter, yes? It's uncoupled. So I think, I'm not sure what's the best way, but WebAssembly goes the middle way, like Java did, okay? So, as I said, it's in all browsers, and this is the roadmap of the browser. And just to explain you here, above are the browsers or virtual machines where you can run the code. That's the WASM time. And these numbers are the versions. It's been enabled. That means it works. That means the feature, oh, that was my browser, by the way. I got a 119 Chrome version. And this is just not in a release, but in a beta or nightly. And Firefox is quite well. There's only one thing that's one feature's missing. One feature's missing. But Chrome really is much advanced here, I must say. And also, when I made a small test, oh, wait a minute, I want other thing. It's just the design, it's complex. All I wanted to show is that WebAssembly can talk with existing JavaScript. So you can have your Rust source code or your C++ code, and you can take advantage of existing JavaScript libraries, all the ecosystem that exists out there. And yes, the other thing is from a paper about vulnerability, which is interesting, but not a little bit off topic. So that is how it looks like. There's an example, which is a little bit outdated. I hadn't got the time to compile it myself, anew, but I was asking Thorsten, so where do I load and save now? And I want to test it with my own documents. This works in the latest sources, but not in this version. I'm not sure why he hasn't got any CI/CD, but I will check on that. And it looks pretty well. It looks exactly like the browser. You can edit. It's a little bit slow in resize, but wait a minute. Yeah. The worst thing is it's slow in loading. Look, it took 43 seconds on my hotel here in Mexico, which but I don't think it's a matter of the internet. But it's 47 is quite a thing. But on the other hand, if I just want to have LibreOffice on a platform where I don't have it installed, it's also all the LibreOffice installation. It's a very easy deployment. It's fine. I can load it maybe on my TV and then edit it, and I can wait for 47 seconds. Unfortunately, Firefox, I'm not sure if you can read it. It took more than 7 minutes. Yes, and I just tested it on Windows. I had got little time. So to sum it up, the advantages of Lava is that you don't have a duplication of source code. You don't have to reinvent the wheel. You don't have to write XML with JavaScript again, but you can reuse what you have. And yeah, duplication is always bad. Otherwise, you fix the bug here, then it's on the other side, you forget. So it's like half of the work. And of course, the deployment is not very easy. You get for free all the platforms that a Chrome browser is in. You're standing on the shoulders of giants. And that's the third one. The deployment, of course, is easy. I'm not sure. I think the second loading, there should be the Office in the browser cache. So this should be very easy. And you might have it an extension. I'm not sure. I mentioned the reuse of web libraries. Like encryption is one of the topics that were being used. And the last thing what I do like is that by the need of modularization, because that was not in mind when the writer or the Office was built in the 80s and 90s, they've been pushed to put it in smaller chunks to load only what it's been needed. Yes, and by this it become more scalable. For instance, you don't want a viewer, you just want to have a PDF converter. You just want to use and let run what you need. Yes, and that makes it more scalable, or likely more scalable. Yeah, but I remind you, LibreOffice on the browser in general, because there's an intermediate language, is a little bit slower there. But they are they're speeding up it very, very fast. So, what I would like to focus now is on the evolution of Office collaboration. You might say, "Oh, this looks great. Now we have another Google Docs or something." Yes, but it's just in a browser, a single user Office. There's no collaboration. You still have to download the documents and send it to other people. And I want to, because I worked a long time here, I try to make it more clearly for you the steps of the evolution. So in the beginning, there was nothing. There was just paper, okay? We have one user, and he can view, edit the document, and of course, with paper, there's no document involved, and I give it to you, and you can see it, edit, and then later give it back. So, and that is the process, yes? And the same process happens when we switch to digital documents. Now it's easier to edit, right? You don't use, we call it Tipex. Yes, you don't, oh no, I've got a typo, gosh, yes, and then you have to rewrite it again. And, but this is as good as working with text files, yes? So if you have simply go from paper to this text files, the editing and changing becomes easier. But still we have like a floppy disk or an email, we can send it back and forth, and only one can work. Still it's collaboration, right? But not very optimal. So the next step is that we have change tracking. And change tracking is most likely what we have in the beginning. But change tracking is not so good as it seems. I think it's some kind of not a lie, but it's a hack, okay? So first of all, on the good side is, change tracking is this redlining. I give it to you, the document, you enable change tracking, and then there's, say, something blue which is being added, for instance, and red what is being deleted, okay? That's fine. So far, so good. And you all can see what has been changed, yes? That is better than nothing, at least. But the problem is the implementation. So what they did, Microsoft Office and LibreOffice and the file formats, they simply mark the area that you change and make the earlier state, the earlier wording, they put it aside in a black box. And when you type reject or you press reject, this earlier black box is just moved in there again, okay? So they don't really have an understanding what was being changed. They just know you changed something, I save it aside, and I do it back if you reject. By this implementation, they have some constraints. For instance, I can only swap something back once. I cannot have overlapping changes, because if they are overlapping and only one will be swapped, how they are interleaving, okay? So there are no, and this happens often, yes, that like colors, and you have a text and you have a color that might easily have disjoint changes, but they're still from the area overlapping, okay? This will not work. And it's strange that it's also on the syntax level, like the XML has been saved on the other side. And if you have all the documents, or you have to read all the documents to find the changes, and the most important question, let's say we all work on the same document, is what have you changed? Because I want to only take the change and merge it back into my document. But if you say, I don't know, it's just there, then there's something missing. So this is a hack, this is intermediate, and we don't have something like, oh, I inserted a column at this table at the third column, okay? That would be a semantic change that we need. So obviously, the next step would be, this is the last one, where we want to go. We only have 5. But earlier, there's another step. We can share the same program and the same document. I'm not sure, I played a lot of computer games in the 80s and 90s, and we don't have internet, so when I played with my friend a strategy game where you make a turn, you sit there and have 3 minutes, and then with one seat, and we swapped the seats, so it was a hot seat, because there was always one sitting and playing the game. And this is exactly like Orador Online was working. They are swapping very fast the users, as fast as they know, right? And so we all connect to the same office, we all work on the same document at the same time. But think of that you are in a train with internet, and you go into a tunnel and there's no internet. And suddenly it all breaks up, okay? And worst of it, you cannot edit any longer because you cannot merge. We have no way of telling what I've changed. There's no definition of what it changes. It's strange. We only define the full document, okay? You know where I'm going into. But Congreso is using WebAssembly as well, yes, to at least, if you're alone in a document, then you should at least be able, in this case, you still be working the tunnel. As long as there's no others, it still works with WebAssembly Online, okay, as a fallback. So this is the same document, but online is red, doesn't work. So this is where we want to go. This is like Google Docs works, yes, but what formatting goes, not very good. So there are multiple users can be working on the same copy, yes. This is like source code developers. We work on the same copy of a text file with Git. And this is very similar to the Git paradigm. We can push and pull changes. The very difference is we cannot use like Git lines and text. That's not possible. We have to define our own changes. We go from the syntax level to the semantic level. And we need to define or reverse engineer our ODF. So I don't go into detail. All I want to tell you is that that's the way. We have to do it the same way as Git and the paradigm, and we have to define semantic changes. So in the last slide, I guess, yes. The last slide that I want to show, the others are just some updates from Thorsten that I can just read, but that is what we need. We need an ODF API. So there is a W3C DOM API, you know? Every browser implements this DOM API. It's on syntax level, and the reason, because there is a DOM API, is the reason why JavaScript is able to work in every browser, in Firefox, Chrome, and Safari, yes? For us, every macro, our JavaScript, our scripts are called macros, just work in our office. There's no way it works in a different way. There's no standard on this. And the way to do it is to abstract it from the application, just to, first of all, we have XML. And XML just say, this is the document. We just know about XML. We just define in the standard ODF. But there's something wrong with it. Because XMLs tell you every XML is equal. This is wrong. There are puzzles. There are chunks, like a table. A table is being inserted and deleted as a chunk. And this is a feature. And we have to define these chunks. And there's something like boilerplate, like office body. It always exists. There's no semantic. You can leave it or drop it. There's no difference, okay? And we have to reverse annotate this XML, okay? We have to find our features, a table, a paragraph. We know them, but we have to explicitly name the semantic. And the nice thing, these features also exist in the application, and of course in the documents, and also the layout, yes? So, but it's not named, we have to define it. And the last thing is, these chunks, these puzzles, have certain user actions that the user wants. You know, insert column is such a thing. Insert column only exists at the table, yes? And background, for instance. Another thing, there is not only a feature, but there might be sub-features, like a background color of a table only exists when there's a table, of course. How can you give a background when there's no table, yes? So you have something like a feature tree, and that helps a lot for testing and generating, okay? And the last thing, what we need for the ODF standard is, we are still in the stone age of paper there. You know, my main work is today, I'm working for European Commission on the electronic invoice standard of Europe, yes? And the invoice, the electronic invoice is that I don't print out my invoice paper, give it to you, and you type it in back, yes? The reason why we do it is digitalization. We want to automate things. I take the data that you desire and throw it over the fence, and at any given time, without human interaction, you can understand it. You can take it for your software and process it automatically, yes? So these data silos will or must fall by this digitalization. And one way is by making standards formats of this information that is required. And now for software, think of that's the next talk about the blueprint. A software developer sit down and have to read the 500 pages and write and type it down. It's bizarre. And there's no genius thing. It's like painting my numbers, yes? So it would be much better if we have some data set where we can generate the software or parts of it and the specification. That means digitalization. And if we do that, then more people might join, because it's very hard. Oh, I start a new ODF application. This will likely not happen. Yes? So we have to somehow lower the bar to get new people on board. Okay, so that's the ODF part, and that's my theme at the ODF-TC. I want to have digitalization. I want to have, there's some innovation. And the other thing is that LibreOffice, of course, requires refactoring. Like, we need modularization, and we need might need this ODF API. Yes, so we have a stack of changes that we can read in and jump in. So, I think that's it. Are there any questions? And before you question, the first one who asked the question receives this booklet. Okay, any question? Come on. Sorry, it has to be related to the presentation. Anyone? Ah! Bravo. Do we have...
Thanks for the book. Well, my question would be, especially what's the, I really didn't understand if this was like a compiler of what you were talking about at the beginning. Well, not at the beginning because I arrived late, sorry about that. But what we're talking about, is this like an interpreter? Or it's basically an interpreter that computes faster, all this stuff that you were talking about, but could you please explain further about it, because I really didn't get it.
Okay, fair enough. You deserve it. Okay, so let me go back. Oh, wait a minute. Wait a minute. So first of all, you got it in Spanish, okay? That might help, the PDF. Okay? And the second thing is, where we should start is that, think about, we have two sides. One is the source code that you added with like if and like the programming language that you use, the for loop and conditions and so on, okay? That is very readable. And on the other hand, the computer does not know anything about source code. It just knows its CPU registry. And somehow you have to transform this into that, okay? And this transformation is called compilation, yes? And you can do it now at different points. You can do it once, like C++, when you build it, okay? And then you have this machine code for a certain platform, okay? Or you just keep the source code, like JavaScript, and every browser has this compiler at runtime, then it's called interpreter, as far as I know, yes? And this is a bit, you lose a bit of performance, but then you don't have to deal with compiling for every platform. The compiler vendor, like Google, deals with it, or Firefox. Mozilla, yes? Is it more understandable? You're welcome. Have fun with the book. Okay, anything else? I think I'm running out of time. Sorry. All right. Thank you for listening. Oh, another question. Can I? You got it.
Since the address space of the WASM virtual machine is only 4 gigabytes, how is LibreOffice doing for size there? Like when you compile the whole thing to WASM, how big is it and how much memory do you still have free on the WASM address space?
And that is exactly what I left out, but it's still on the slides. That is what Thorsten wrote afterwards, and he gave. You see, here's the 4 gigabytes, he mentioned it, and here he mentioned about how he's been optimizing it. But I was not involved so long in the project. I was just asked last week if I come here. And on the weekend he told me, oh, by the way, it's no marketing, it's WebAssembly talk. Okay, so I'm just jumping into cold water, and the next time I might speak Spanish, hopefully. And the next time I know more details. I've got myself some questions, but there were some problems in information done. There are other talks, and of course, somehow he solved it. For instance, I can tell one thing. The UNO API, he just removed it. It's a port. So UNO API is that from a different language, like Python, Java, you can speak with C++. But you don't need it, because you can speak later with JavaScript and other WebAssembly or Clang, LLVM languages, yes? So he just coded out all the UNO calls and removed a lot of this source code, okay? So by just cutting out things which you do not need, it helped a lot. That's what I know. Okay. Thank you. Okay, thank you very much. See you soon. I'm going to the other room.